Ladies and gentlemen, thank you for joining so many people to learn more about open hardware today. It's always a pleasure to see so many interested persons. My name is Flo. I'm the CEO from the Open Hardware Group, and today I want to give you a little bit an overview. Who is the Open Hardware Group, what we are doing, and also some of the products we are having. So let's start with who is the Open Hardware Group. We are a globally acting company. We are working on the development of RISC-V cores. Now the cool thing is this RISC-V cores are fully open source. They are industrial grade, verified and documented. This course can be used from anyone. You can take them into a commercial product, feel free. What the Open Hardware Group is doing here, we are providing the infrastructure, we are providing the management between the cores and making sure that you can use it. The Open Hardware Group itself, we are driven by our members, which are from industry, like you can see here. Impera is one of our members, EM Micro, Embacosm, CodaZip, a lot of members here. We also have the academic members which are helping and using this course for research. So for them it's a big benefit to get industrial grade cores which are used in real application and put them in a research project to enhance, to do research. And then there is also partners who are supporting us. The big question is, why is the Open Hardware Group here and why should you integrate our RISC-V course into your next project? Well, that is very easy to answer. Today you have basically two choices. You can use licensed core from an IP vendor like Endis Technology or SiFive, and these cores are great. They are relatively not so expensive and they get you started very soon, but they not always allow you to modify all the things. So that's the second option. You can develop your custom in-house core. You can have all the flexibility. You can add whatever you want, and that's great, but it costs you more money and more time. The Open Hardware Group is now offering something in between. We are providing you a fully open source core, and you still need to have developers in-house because we don't have the same service level like someone like Endis, for example, but you have the full customization and possibility to add the core as you want, but you don't need to do everything from scratch, and you can share your development with other companies, with other members of the Open Hardware Group. Now, that's why the Open Hardware Group is here. Let's have a look what the Open Hardware Group is doing. The main product we really have is the core. We have a family of cores. There are currently 3 members in, and these cores are all under the Apache 2.0 license. You can take them, you can put them in an industrial product, no problem. You have all the freedom you want to do. If you're working for a big corporation, your legal department, they will be familiar with the Apache 2.0. It's used in all the software which is used in industrial applications. Easy to implement with your company. The core itself is written fully in System Verilog to make it also good for industrial usage. That is what is used widely today, so perfect for that. Then the second layer is the verification model. If you really want to put it in a commercial product, you need to have also verification workbenches. We are providing all this verification, UVM, System Verilog 2.0 based. You get all the things. It's working with Siemens MentorQuest, with the Synopsys, with Cadence, so no problem. You name the vendor of your EDA tool, our course will be supported and easily to be implemented. Then Open Hardware Group is going one step further. We are also providing the software. So a core without software is nothing, and that's why we have the compilers, LLVM, GCC, very important, but also real-time operating systems. And last but not least, also support for Linux on top. Here, for example, Red Hat is a partner or a member of the Open Hardware Group. They are also helping to port the Fedora on the latest cores, making Linux ready on RISC-V. Now, another important point if you go for commercial integration is documentation. If you have developers working on this, they need to have documentation how it's working. That's also what we are providing for our course. And then last but not least, we also have a hardware part where we have images for the FPGA, so you can use it and run it on an FPGA. So that's what the Open Hardware Group is doing basically. That's our project. The course, as you can see, is very important, but also test benches, documentation, the software stack, and also some verification like on FPGAs. Now, I told you we have a family of cores. That's what I want to show you on the next page. We are starting with a very small core, the CVE2 family, that is for deeply embedded cores. It is equivalent roughly to an ARM M plus M0 plus. Then our CVE4 family, here we have different cores. Some are already taped out, so in total we have a shipment for all the cores together in over 500 million of commercial shipments of this course. CVE4 family, as I mentioned, that is also used by a lot of our members. And then last but not least, we also have the CVA6 family. The CVA6 family is an application-ready core. It has a few different configurations. So the highest configuration is similar like an A55, but now some of our members are also working to remove the MMU and make it a dual issue, and that would be then more like an ARM M7. Like I said, Open Hardware is an open source, so we also have some kind of school project. It's called CVW or CV Valley. That is for a textbook where students really can learn how to integrate RISC-V with System Verilog from scratch, and that's why we do have this CV Valley here. Next, I just want to give a very brief overview how the Open Hardware is organized. We are organized by technical working groups. Like I said, we are a non-profit, globally operating, and we have a board of directors who do, of course, all the approvals. But then for the technical side, we do have a technical working group, and you can think about this technical working group like a central R&D. So here are all the decisions made, what Open Hardware Group is doing next, how we are doing it, which direction we go. And this technical working group is steered by some of our members, and all of the members can join this and can take part in the discussion, in the decisions, how we will do things next. Under the technical working group, we have different subgroups like the core task group, which really, like the name says, take care of the cores, special task group for verification, software, hardware, and then the gentleman asked if you're also going for automotive. Yes, we do, so we have a safety and security task group. But that is work which is starting now, so if you're interested in it, feel free to join us and contribute. There is also a marketing working group, and there are different working groups for Europe and for Asia, just to make it more easier for bringing people together. I want to dive a little bit into it. I only have two groups here, so you can see the technical working group, that's what I just mentioned, which is very similar like what central R&D is representing in a company. And you can see this technical chairing group is chaired by Thales right now, Jerome, very great guy. And they are really doing the technical direction, they are defining where we are going next. Then under the technical working group, we have some subgroups. I'm not going into all of the details, that would take too much time, but if you're interested, feel free to contact me. So the course task group, which are really looking for the course, the implementation, they are chaired by Arian from Silicon Laboratories, but also Jerome is here co-chair. And coming a little bit to the history of Open Hardware Group, so a lot of our cores originated in ETH Zurich. They had good code base, so Luca Benini and his team, big shout out, they did a great job, and we basically took the Pulp platform and bring them to Open Hardware and verify them for the industrial application, for the industrial use. The hardware task group, just what I mentioned, we are also providing images for FPGAs. We have some IDE together with Ashlink and inside the compilers from Emberkossen, and that really allows you to take the cores, you can modify them and compile them for these FPGA platforms, or you can find ready-to-use FPGA images on our website if you just want to test the board. So I think it's also great to have a faster time to market. Then something cool, Sometimes we also do chips to verify our IP. We are very happy that GlobalFoundries is a partner and member of Open Hardware. So GlobalFoundries from time to time is giving us some shuttle where they are taping out some of our chips, allowing us to verify it. It's really great. There are a lot of partners coming together for this project. We had, for example, Espressif for working on the Internet of Things connectivity. Inside we have Dolphin Design, we have Embercosm for compilers, Ashling for the IDE, QuickLogic for an embedded FPGA core inside. And that's a very key point about the Open Hardware groups, that we really bring together industrial players to enable cores which can be reused and then also verify them. And having real silicon is just part of the verification to really make sure it's working and give people the possibility to use it. Then one last thing I want to mention, there are also global projects. So here in Europe, for example, we have from the CHIPS joint undertaking the project which is called Tristan. Tristan is aiming to create an open source platform of embedded up to application cores. And here, Open Hardware Group, we do have this course already. So we became part of the Tristan project. We work together with the Eclipse Foundation here to have the Open Hardware Europe working group, which has a European entity, a German entity. And over this way, we are participating in Tristan and enabling the RISC-V ecosystem in Europe, enabling startups, enabling old industries, big industries, so everyone is welcome to adopt and use this course. All right, then let me give you a very short overview about the course we are having in Open Hardware Group. I, because of time limitations, only pick 2 cores. But before I jump to the course, I want to talk with you about industrial usage and verification. Maybe you are aware with these terms. So there are the terms technical readiness level, TRL for short, something the NASA invented, and it describes which kind of quality your IP has. So normally if you have a university and they do a core, they have some proof of concept, TRL3. It is good to put it in a chip, but you maybe don't want to ship millions of cores. So the target from Open Hardware Group is to take this course, which are from industry or from academic, and bring them from TRL3 level to TRL5 level. That means fully verified, fully tested, documented. And then when we reach TRL5 level, we will freeze it on Open Hardware side, and our members then will bring it to real silicon into real chips. Like I said before, we have of our course a combined shipment over 500 million. That is actually quite a success story from our point of view to have this open source course really shipped in high quantity. Just give you a short overview about some of our cores. So the CV32E40P version 2, quite nice core. It has some pulp extension, which is a DSP extension or a custom extension, so to say. We have fully support for the GCC and LLVM. There is also hardware loops inside. The whole core is a 4-stage pipeline, and like I mentioned, everything here is open source, so you can get it from our GitHub. Another core is the CV32E40X, so you see only the last letter has changed, the rest stays the same. This core here is specially optimized to add custom instructions via the X interface, the CVXIF. This X interface, by the way, is a specification which was also developed inside Open Hardware, driven by the members of Open Hardware. It is defining the electrical signals, how to combine a hardware accelerator very close to your core. Then the last core I want to introduce is the CVA6. The CVA6 is a 6-stage in-order single-issue core. It can be configured to 32-bit or 64-bit. It's our Linux-capable core. We have this actually also in a configuration with cache coherency and multi-cores, 2, 4, and up to 8 cores running. The core itself is also worked on, so currently there is a project to create a new core based on this with dual issue capability, for an embedded version, also driven by the members of Open Hardware. I don't have enough time to go over all the details of the course, so I just had this short overview. I hope it was interesting for you. I will be around if you have questions. I would be happy to take your questions. Please make sure to check us out on openhardwaregroup.org. There you also find the ways to our LinkedIn. You should subscribe, Twitter channel or our YouTube channel, and also on the GitHub where you can download the course, where you can test this course. And if you have any question, feel free to give me an email. It's flow@openhardwaregroup.org. So great. Thank you everyone for being here. Thank you for listening and looking forward to work closer with you.